Alright lads and lasses, welcome along. It's time for another Tuppence Tuesday. This is a real tough subject that you've really got to get your head around in Power BI. So I'm going to try and have we'll skim it today and hopefully you'll kind of go, alright. And then we'll have a think about it and we'll come back. In fact, now we're going to come back to this and revisit it. I've just had more calls as well with work about something very similar. So let's try and get into this, see if we can make some sense of it, see if I can explain it right for you. Hi. So database versus tabular. Hi. One of them things people can, I'm going to build a tabular data model. I've got these like dimensions and fact tables, haven't I, and all this sort of stuff. Let's understand my data that way. And that's really easy to get drawn into the whole, it's a relational database structure. And a tabular model is relational. A database is a database and it's relational as well, normally. Yeah. The problem is the way they use the data and the way it sits in it and how it's optimized for use. So let's see if I can try and explain it and see if I can make some sense of it for you. So a database is obviously designed for records. It's also like optimized for mechanical hard drives. Even now, this day and age, traditional SQL databases, they're optimized for a mechanical hard drive. Who knew? It's kind of like, that's the design. So records are thought of as a continuous set of data, and as much as possible, rows are stored together. So all the columns in a row are stored together. It's a row that you're looking at. Tabular is designed for aggregation. So we want to do something with a column of data. We don't care so much about the row, we care about a column. So a column is what's important to it. And it's been optimized for RAM. And a combination of those two factors between what a database is and what a tabular model is always going to lead to the shaping and the steps that you need to go through as you go from your source data to your Power BI data model that we can then run DAX against. Yeah? Everyone's still with us? We are, you see. Of course we're with you. So here's an example, yeah? In a database, we've got this kind of a table. And we'd access it with a select statement. So I might say, select start from invoices where customer is 010. And we get these two rows returned. Yeah, well, these rows of data, and we can see them two that match what criteria, them's returned. Aye, we can see that makes sense to her. That doesn't make sense in a tabular data model perspective and in DAX. And that's one of the things you have to understand. So DAX is going to be running something at a column level. And in this case, it's wrapped in a calculator here because we need to filter it. But the core piece is, I want the sum of the total. But I want the sum of the total where customer ID equals 010. So these two. So all I'm going to have is one value back. Put it in a table. It wouldn't really be a table to put it. I couldn't think of the right way to put it. A table, alright? And we've got a value. So I haven't got a row of data anymore. I've just got a value. I've got a scalar value returned, single value. And that's something that when you start to think through how your structure is built, will influence an awful lot for you. But it's difficult until you really see it in action. So I hope having that little bit of alright has made a difference, but I don't know if it has. The other thing is, because it's built for aggregations and because it's built for columns, it doesn't really matter so much about how many rows you have. It's more about how efficient and narrow it is. And so you'll hear Microsoft talk about the billion row data set that they've done of New York taxi journeys and stuff like that. Now, I've not had a look at the raw data in it, but I'll be willing to bet money that the billion row table has less than 5 columns or around 5 columns kind of thing. You've probably got like a taxi ID, a date time, and a latitude and a longitude. That's 4. That's all you really need for that, isn't it? Where was this taxi at this date and time, and some coordinates for it. 4 columns. That's all you need. You have a billion rows of that. That's fine. Because what Power BI will do is it'll compress each column. And the more columns you have, the harder it is to compress it. So I've had a think and I've kind of come down with a nice little demo that I think will make sense to you. So we'll have a look at that demo and see if we can then come back to here and see if some of it's sunk in, yeah? So I've got this Power BI file here, yeah? And let's have a look. So it's 338 kilobytes in size, yeah? Now, if I have a look at the data that's here, if I have a look at the table, all I've done, I've just, shamelessly used the COVID data set again. It's just the confirmed count, yeah? So what we've got is we've got lots of records. It's really wide, isn't it? Really, really wide. Okay? Now, if I turn this round and I say, right, let's see what it would look like if we looked at the formatted table, so the one that's actually going to be used. So what have I done? If we go to the transform data section here, bring this in the right place, here we go. So here's our transform data, and you can see this is the raw version. Alright, we've just pulled this table of data, promoted the headers, and filtered the rows. We've removed the US, because the US is this US data set that we've also combined in when we've built it. In terms of this, it's like one row that's been removed. That's 300 kilobytes for that. If we come to here, this is the one we use, right? This is the main data set. This is how we process our data in the COVID report pack. You see it's got 4 columns, that's all. We've pivoted it around, so we've unpivoted these other columns. So we've gone from it being like this to it being like this. Tall and narrow, yeah, long and thin, whatever you're going to say. Tall and narrow, right, data set. So lots more rows, less of that. So what happens if we switch these over? Alright, so if we come in here, we're going to tick that, or untick that to remove it from being loaded, and we'll load this one, alright? And then what we'll do is we'll come back to close and apply. And here, let's go and close and apply. And Power BI is going to go and build that. And it'll take it a bit longer than it would to do this, to build it. And then let us scan through and go and file and save. And then let's have a look, see what's that actually size now. 238 kilobytes. So we've done nothing else but swap to a more compressed structure, and you see that's brought it down by a third, right? I can assure you there's more ways you can do this. You can take this further, but I hope you can see that just the act of changing how it's structured, we've got the same amount of data in here and it's much more efficient. What I could also do though is we could quite easily say, do you know what, if the values are 0, let's get rid of the values that are 0, save myself even more money. Well, not money, but it might be money, it might be paying for storage, but save myself even more space. Not interested in that. We might say we're not interested if there's less than 100 cases in anything. We could do that really quickly and easily because it's one column here. Could you imagine trying to do that in the other data set, in the raw data, which one's got less than 100 in it? It would be a long piece of work to do. And this is where you start to get into the secrets of Power BI and actually what's going on behind the scenes. Because what Power BI is going to do is it's going to do an aggregation on that. And all we're really doing with this COVID data set, if we have a flip back over to it, all we're ever really doing is a sum. What's the sum of the latest confirmed, where it's in Afghanistan? And the latest confirmed is just where the latest date value is for it. So what's the latest date value that I've got for Afghanistan is what we're saying. What's the sum of it? And there's going to be one value, so a sum of one thing. That's easy enough, isn't it? That's not difficult. But consistently, that is how Power BI works. It will go through, it will piece together your data sets and build up what you need into value strings or columns that can then be filtered to get you what you want. So we could be saying, right, I want the latest date value that you've got. So I can click here and go right down to the bottom, 30 to the 6th, so it was that value, right? And you can see, so that first one I showed you, all it's looking at really, if we sort this key, sort of ascending, Afghanistan. So I've said, get me a sum of that. That's easy enough to do, isn't it? We could do all sorts based on that, but all we're ever looking at is one column. So I can say, what's the average? What's the growth? What's this? What's compare? It's a filter statement. And that's how Power BI works. But you're always working in terms of a column of data. So your aggregation function is always going to be key, and then you'll be filtering around that. Does that make sense? So have a think on that. It's taken a bit longer than I was hoping, but hopefully it's going to sink in, and we'll keep coming back to this, I'm certain. Right? For now though, take care, and we'll catch you on Friday for something for the weekend, yeah? And honestly, it'll be a great one this Friday. Cheers.